In this question, we're asked to find the value of Kp given the value of Kc. And Kp and Kc are relatable to each other. Remember that Kp uses the pressures of the gases, and Kc uses the concentration in molarity. So in order to relate these things, we have an equation. Kp equals Kc times RT delta N, where delta N equals moles of product minus moles of reactant. Note that this is moles of gas. If you were to have something in here that wasn't a gas, you wouldn't consider it, just like you wouldn't consider it in the equilibrium equation. So in this case, let's figure out how many moles of gaseous product we have. Well, in this case, we have 2 moles of gaseous product. And we also have 2 moles of reactant, 1 mole of hydrogen and 1 mole of iodine, which means that delta N is equal to 0. So if you look here, Kp equals Kc times RT raised to the 0. Anything raised to the 0 power is 1. So Kp equals Kc times 1, or Kp simply equals Kc. So if there's no change in moles between the number of moles of products and reactants, if they have the same number of moles, then the Kp equals the Kc, or in this case, the Kp simply equals 8.65 times 10 to the 3. Now, you don't necessarily need to go through all this math. I just wanted to show you one example like this, because sometimes the Kp and the Kc are equal. When are those times? When the moles of product, the gases in the products, and the moles of gas on the reactant side are both equal.